The seemingly impossible, paradoxical news that astronomers had taken a picture of a supermassive black hole captured our imaginations in 2019 for good reason. What they actually showed us was a sort of shadow, a spherical blackness surrounded by a cosmic hurricane of matter and energy, but that was enough to qualify as a sign of real human progress. And so the April announcement rose above other, less hopeful science-related news in 2019: global warming, plastic overload, disinformation, drug overdoses and unaffordable medicine. Science, Nature and Science News all flagged the photo of the supermassive black hole, weighing an estimated 6.5 billion suns, as breakthrough of the year. Getting that now iconic image relied on technology that did not exist at the turn of the millennium. The leaders of the project said they counted on Moore's law to bring the electronic advances they needed. The image was constructed from radio waves picked up at 8 far-flung telescopes, from France to Hawaii to the South Pole. And it was just the beginning. Insiders now say they are on the verge of announcing a second image from this array, now consisting of 10 telescopes, which is collectively called the Event Horizon Telescope. In 2020, we will get an image of the supermassive black hole known to be lurking at the center of our own Milky Way galaxy. The black hole image from 2019 is located in a distant galaxy, called M87, and while our black hole is much closer, it is also a factor of 1,000 smaller. In subsequent months and years, the team plans to create sharper, more accurate, less noisy images. They call these early shots rough cuts. Despite all the bright stuff surrounding black holes, it's impossible for any single existing or planned telescope to see that central shadow because it's tiny on a cosmic scale. For M87, that bright ring is about the diameter of our solar system. Getting that image from 55 million light-years away was, the astronomers say, the equivalent of resolving the shape of a donut on the moon. The bigger a telescope's mirror, the smaller the objects it can resolve, and to see that distant donut would require a mirror about the size of Earth. But there's a trick, by which astronomers can coordinate an array of telescopes so that they act as pieces of one big telescope. That's why it makes sense to call this disparate array the Event Horizon Telescope. The name refers to the theoretical limit beyond which light can't escape a black hole's pull, though the distorting effect of the black hole itself makes the visible shadow a bit bigger than this. Albert Einstein himself was skeptical of the existence of black holes, even though people used his general relativity theory to predict that a big enough star might collapse to a point of infinite density and shroud itself behind a boundary even light couldn't escape. By the 1990s, astronomers had proved that black holes existed in the real universe. They did it by observing stars whipping around invisible companions, the motion suggesting an unseen mass too big to be any sort of ordinary matter. Around the same time, astronomers used the Hubble Space Telescope to view stars and other stuff swirling near the centers of galaxies, and calculated that the most likely explanation for their motions was the pull of a supermassive black hole. Scott Tremaine, an astrophysicist at the Institute for Advanced Study in Princeton, said he's excited to see the image of our galaxy's own black hole, called Sagittarius A, because other kinds of observations have hinted that it's spinning with a certain orientation. Will the image bear this out? He's interested in whether the mass calculated from the image matches the mass estimated with other methods. And there's always the hope that the shadow won't be a perfect sphere as predicted, but some anomalous shape requiring new ideas to explain. It's still not well understood how these supermassive black holes form, said Aaron Bonning, an astrophysicist at Emory University. There's not quite enough time in the age of the universe for the most massive of them to form unless they started from some large seeds, perhaps bigger than the kind of black hole formed by a collapsed star. We should get more information from the James Webb Space Telescope, which promises to see out in space, and therefore back in time, to the cosmic dawn when the very first stars and galaxies were taking shape. It will also promise to extract all sorts of information about planets orbiting other stars, including which ones have atmospheres with water vapor, methane, carbon dioxide or oxygen and are therefore most likely to be harboring life. The good news is that so much is within the reach of 21st century technology. The bad news is the telescope, like so many ambitious projects, is billions over budget, and years behind schedule. No matter how advanced we humans become, some things never change. The seemingly impossible, paradoxical news that astronomers had taken a picture of a supermassive black hole captured our imaginations in